everyone. Welcome and thank you for joining us today. My name is Jody Lee. I'm with Harris, and I will be moderating this webinar, Delivering On-Demand GeoAnalytics at Scale. I'm excited to be joined today by Dan Conser, Senior Product Manager at Harris Geospatial Solutions. Dan is responsible for the success of the enterprise product portfolio and helps bring innovative solutions to market for the government and commercial customers. We're also joined today by one of our partners, Dr. Jamie Goodman, who is the founder, president, and CEO of HySpeed Computing. HySpeed is a technology company specializing in developing advanced algorithms and analytic tools for the geospatial community. Just a couple of housekeeping items before we get started. I've muted all the phone lines for the attendees, so if you have any questions at any point during the webinar, enter them into the questions chat box. The presenters will try to answer as many as they can at the end of the presentation. We are recording this webinar today. We will email you a link of the recording today, and then we'll also follow up with a PDF of the presentation as well as some other content that you might like in the next couple of days. The webinar will be posted on our website at www.harrisgeospatial.com, and we encourage you to share it with your colleagues. So without further ado, I'm going to turn things over to our first speaker, Dan.
Good day, everybody. This is Dan Conser. Welcome to our webinar, and thank you for joining. I'm going to go quickly over the agenda to describe what we'll be talking about today. First, we're starting out with an overview of who we are here at Harris, as well as HySpeed Computing, and then really define what we have, the term GeoAnalytics at Scale, so that everybody's on the same page. We're going to go through what we've done here at Harris Geospatial with our Geospatial Services Framework, show you some example applications, and then Jamie's also going to really talk about the ecosystem that he's been involved in and some of the great custom work that he's been doing. And we'll wrap it up at the end and also have some time for questions. So hopefully everybody is excited to get started on GeoAnalytics at Scale, and we're going to just jump right into it with a little overview of who we are here at Harris Corporation. Back in 2015, our organization was acquired by Harris Corporation, but we're a global organization with about $6 billion in revenue. We're really made up of engineers and scientists coming from over about 100 countries, and we're really strong in research and development. And we work really with the United States government on many levels, and then we also work internationally with a number of governments and organizations. Our particular segment is divided, Harris is divided into 3 segments. Our particular segment is called Space and Intelligence Systems, which you'll see over there on the right. And really, we're in the Earth observation business, and we've been flying payloads on satellites and sensors on satellites for pretty much since they've started. And within Space and Intelligence, we've been broken up into different groups and different business units, and our particular area is under the Geospatial business unit, which is down in the bottom. And we do have some wonderful partners and organizations with environmental. We also have some space superiority that we work with, as well as many of our customers we share in common with other organizations, other parts of our organization. Now, Harris Geospatial Solutions, we've actually been around a while, and I've added a slide to really show you where we started, but we have really everything from sensors to software, and we do really deliver answers to a lot of our customers, and we do that in a number of ways. We've been focused on NV and IDL, which are some of our core products here, but we've also recently added, because of the Harris acquisition, a number of other wonderful sensors like Geiger mode LiDAR and Jaguar. We got our start, and I think this is important to know that we've been doing this for a long time. Back in 1977, we really was where we were born, and that's part of our IDL language. We were working, our founder of our company basically had a team of scientists working on the Mariner Mars space probes and needed a way to scientifically, analyze that data and visualize that data. And so we started in that. We moved into geospatial with Envy in the desktop software in 1991. So as you can tell, it's almost been 30 years we've been really working in geospatial, advanced hyperspectral image analysis and geospatial area. So with that, I am going to allow Jamie to introduce himself, and he's obviously been working with us for a while. So here's Jamie.
Thank you, Dan, and hello to everyone. It's a pleasure being here today and speaking with you all. Yes, let me start by providing you with a brief overview of high-speed computing. So at its most fundamental, we're focused on developing next-generation geospatial apps that transform geospatial data into actionable information. Now, the objective here is we want to put the users first. We're delivering to deliver information that people need and formats they can use. This is kind of the new paradigm and the new ecosystem, the new geospatial ecosystem, which we'll talk about a little bit more later. At the same time, we have an extensive background in geospatial science with expertise in remote sensing, scientific research, software development, cloud computing. So all of our products are developed using sound scientific principles. They're designed to be inherently scalable for use in on-demand and enterprise level on-demand cloud and enterprise level computing environments. And they're specifically created to meet the needs of both geospatial scientists and these non-specialists, okay? So we want to kind of help democratize access to geospatial products and geospatial information. However, obviously we can't do this alone, and an entire ecosystem's needed to meet this objective. So this is one of the reasons we've partnered with Harris to build our applications on their industry-leading geospatial software framework, including both Envy and GSF, which is one of the reasons we're here today. We're also partnered with other service providers such as Cloud.io and PrecisionHawk in order to reach as broad a range of customers as possible with our applications. We're going to show you a couple of those later in the webinar. And we're looking forward to sharing more with you during today's webinar, but for now, let me turn it back over to Dan for an introduction to GeoAnalytics at Scale and GSF. Dan?
Thanks, Jamie. So before we dive in, one of the things that we were talking about is we're really curious about our audience. And so we're going to ask a poll question now. And I think, Jody, you have the poll question to show.
Yep. Do you currently use any of the solutions, any of our solutions or products? Check all that apply. I'll give you guys about 15 seconds. And here are the results.
So it looks like a fair number of you are familiar with the Envy and IDL packages that we offer. But that also, with about half of the folks that have contributed, we also see that people may not have heard of us or may not be familiar with our Envy and IDL, and that's okay too, because what we're looking at is really a little bit broader scope than just our history of Envy and IDL. We're actually looking at a much bigger ecosystem, as Jamie's going to talk about, and our particular role in that ecosystem. So, well, thank you for participating in that. Now I'm going to move on to the title of this here. So, delivering on-demand geoanalytics at scale. Before we talk about actually delivering it, let's break this down a little bit and talk a little bit about what we mean. So, first, geoanalytics at scale. We've used this term, and in the industry, there's a number of terms that are very similar, and so trying to understand what that means. When we started, we were really working on some spatial information, and I think that's still relevant these days, and really something that a lot of folks provide. But the real area that we focused on, and some of our real core competencies, were in the spectral area and looking at the light spectrum that exists. And this is one of the things that I think David Stern focused on, early on, was the hyperspectral and the multispectral data that comes out of an image or comes out of a remotely sensed information. And then lastly, some of the temporal aspects. What really, looking at things over time and understanding how things change over time. That's another part of this geoanalytics spectrum that we're working on. And really, we're just saying that, any analytics or any advanced analytics that deliver geointelligence. And because of that word GeoInt is might be somewhat new for our more international audience, we're going to break down geointelligence a little bit. We do a lot of work with the NGA, which is the National Geospatial Intelligence Agency here in the United States. And the term geointelligence or GeoInt, basically, and I took this from Wikipedia just so that we could talk about it, it's really a broad area, but it's really looking at imagery intelligence. It's looking at, satellite imagery, remotely sensed information that you can turn into intelligence. And that's something that's very important looking at the human activity on Earth. And there's a lot of folks that are trying to do this these days. This is what we're trying to deliver. So geoanalytics, and we're going to use these terms probably a little synonymously today with these analytics and this intelligence, but really analytics are providing that geointelligence. So then the next part of GeoAnalytics at Scale, one of the things that we talk about is what does it mean to scale, and what kind of scale are we talking about? And so I tried to put together a brief overview of an example. And so this is what we mean by scale. There's a video services framework that's out there today that serves over 99 million members in over 190 countries. And you can read this. They watch hours and hours of video per day. These are large files. They can play, pause, and resume watching them as much as they want. And obviously, this is a very valuable company that hopefully those of you on the phone are familiar with. And it's over $60 billion as of the earnings call yesterday. And you may have already guessed it, but that's Netflix. And so they've built their framework to really handle scalability. They don't think about the scale anymore. They think about the content coming through that. And I'm only using that as an example to give you guys a definition of how we've thought of this problem, how to deliver on-demand and batch analytics at scale, because I think it's important to understand that that's the kind of scale we're talking about. We really want you to be prepared to not just start today with your operation and your organization getting started on it, but also be comfortable that this can scale to a global enterprise for your organization. So next, we have another poll question, and the reason for this, now that you understand GeoAnalytics at Scale, we want to understand sort of when you're looking at deploying that. So Jody, can you show the next poll question?
Yep. When are you planning to deliver GeoAnalytics at Scale? Okay. And here are the results.
Okay, so it looks like some folks are, less than in this year, in this, coming term, and some people are already doing it, which is wonderful. And even for those of you that are looking over a year, I think it's something that as you start to hear about how we're looking at this this large scale problem, you might see that there's a solution that might be right for you in your particular environment. So thanks, Jody. So when we started to look at this, the landscape that's out there, I don't know if you're familiar with this, but it's very, very crowded. There's a lot of solutions and a lot of words, and we've sort of branded this as cloud insanity because there's a landscape of folks, a lot of our partners, a lot of people doing things, and we really value each and every one that are coming at this from a different angle. But we ultimately had to look at this from our perspective and our clients' perspective and how they wanted to scale. So while you can pull together a lot of the pieces of the puzzle here and start to look at that, what we looked at was how do we deliver this both in a batch mode and an on-demand mode, and what are the key criteria that we really, really want to focus on? Well, one of them, and I'm going to talk a little bit more about this, but I'm going to give you a summary, is we really wanted this to be cloud native. We didn't want to take something that we already had and port it to this new cloud infrastructure. We wanted to make sure that this thing was born on the cloud. This only runs, in the optimal way that cloud infrastructure is built. another key criteria was we wanted to look at this as a data agnostic solution. We wanted to make sure that we weren't tied down to any specific data type. And I mean that sort of in a bigger sense, not just even imagery or radar or optical, but it could also be big data. You know, we all carry sensors in our pocket right now with these mobile phones and smartphones. We have a lot of sensors that are out there, you know, Internet of Things kind of generating data. How do we bring all of that together to really deliver geospatial intelligence? And then lastly, I was at a conference recently and I heard this term about democratization, and they were particularly talking about artificial intelligence, but there's a definite push in the industry to democratize GEOINT. And what that means is no longer is it what we got our start in, which is just scientists really looking at problems and really trying to, you know, process the information, analyze the information, and then visualize it. This is really a chance for really producers and consumers to come together where maybe the user is adding input that makes the machine learning smarter for image recognition or object recognition. So really democratizing it and delivering GEOINT across the full spectrum of folks that are involved in this industry. And so when we did that, taking these criteria, what we created was what we called the Geospatial Services Framework. And basically, I'm going to describe a little bit more about the Geospatial Services Framework, but it's our server software that has recently been created last year, and we've been focusing on batch processing, but we're also working with on-demand processing as well. And I'm going to talk a little bit more about, we call it GSF, but I'll try to call it Geospatial Services Framework. So what is GSF? Really, it's a server framework that we designed specifically to do the scaling of geointelligence, and you see that in there. I want to make sure that I can level set a little bit about what is a server framework. So for some of you, this may be pretty redundant, or you may already understand this, but this is server software. This doesn't run on a desktop in this traditional way. It's really built for a server and that server infrastructure. And there's many benefits of having server infrastructure, and you can see them that I've listed them here. One of the key benefits that I think about is sharing and collaboration, and really that democratization of GEOINT. And I think that's what GSF has been providing our clients for the last year. So as I break down how we went about this, we looked at the open source community, and the program that we chose to really focus on was Node.js. And that's really what we built GSF on. And we feel very confident in our decision that we chose something that is really a foundation that we can build on and deliver over time. It's really, out of the box, Node.js does a lot of things that we can utilize, but we also wanted to make sure it worked for our industry of geointelligence. So to deliver GeoAnalytics, we had to make sure that there were a lot of tools that were built in that really out of the box, you could get it up and running and you can work in your environment. And I'm going to talk a little bit more about this later, but also that you could extend it. And we wanted to make sure that if you were really trying to run an operational production environment, that you could really have all the features and functionalities of communities. And I've listed a couple here. One of them is the Node Package Manager, which is NPM, and another one is GitHub in the open source community. But it also goes to communities like Esri. You know, we work with so many wonderful partners. We've got so many communities, and you can really extend the functionality of GSF to work with those, or you're even on-premise and your homegrown solutions that you've come up with. So GSF out of the box includes some of the fundamental tools that we that are needed. And I've built this slide. On the next slide, it goes into a little bit more detail, but I'm going to talk a little bit about it at a high level so that you can see the different components. So the request handler, it's really the endpoint for hypertext transfer protocol, or HTTP. It's a REST-based API. These endpoints are important, to make sure that you have jobs, it's getting statuses, and make sure the resources are available. The parameter mapper is the next one that you see there. That's really how we map resources. So this is, there's a lot of open data on Amazon or Google or Microsoft these days. You want to make sure you can get to those resources and translate the inputs and outputs It also includes GeoServer and even our own ENVI data sources. We want to make sure that those are all recognized. You don't have to write all this down because the next slide is going to have a lot of the details that I'm talking about. And the most important one to us is the engines. So we've not only built this to work with our engines, which is ENVI and IDL engines, but also we can work with our partners. We can work with off-the-shelf like Python engines, Fortran engines. We can basically wrap any API that the engine provides and make it a JavaScript module that defines tasks and makes them available for engine execution. So if you have a very complex workflow, you're able to bring all that together with GSF and really make it go from beginning to end and not have to leave the Geospatial Services Framework. The next one, Route Mapper, a lot of our clients are doing some of the higher end processing on GPUs, and this allows you to have a queue, where there's a real high performance route that uses a graphics processing unit to make sure that that's available to really speed things up or do some calculations that aren't available on a traditional CPU. It's also a lot more money, so you want to make sure that you can define those routes accordingly. The Workspace Manager is really where all the work gets done, and that's something that GSF can bring together in one common place so that you can share local resources and cloud resources all on the same workspace and get the answers you need. And then lastly is the Job Manager. That's really how jobs get submitted and they need to be processed or analyzed or visualized. And this even allows you to use your own Job Manager if you have one already. This slide right here really details all of all that information I just mentioned, but I wanted to sort of talk about that because that's what GSF is a little unique from Node.js, and that's the 20% secret sauce that we've built in. So I want to go back and talk a little bit about what we mean by a cloud native. So it was born on the cloud. We really have architected this to be compliant with all the major providers, with the Amazon, Microsoft, Google. It can be on-premise, which means you can also host this yourself on your own infrastructure. We could do it off-premise. You can do both. You can have a hybrid infrastructure. It also works on its own. We run it on our own standalone, and it can be the center point that works, that really is the centralized area for you to run your geospatial intelligence. And then lastly, of course, we work and we integrate with all of our partners, integrates with all the web servers that you may have and the applications that you may have. And that's one of the beauties of using Node.js. So now about data agnostic. We put this really together that any remotely sensed data, one of the beautiful things that our background, we really work with almost any remotely sensed data that's available, and it's something that we continue to add to that, the full spectrum of multispectral, hyperspectral, LiDAR, anything that you can sort of bring to the table, we believe that we can open that information and make it available to you. We also are working with all the commercial providers, and there's a few of them listed here, and we even have the ability for you to bring your own data, and we're seeing that more and more where people are saying we have our own data, we want to make sure that's available to our scientists, make sure that's available to our users, because it's important for us to bring all of this information together. So now with GSF you're able to do that. So the last piece is around the democratization, and I had the good fortune of going down to the Space Symposium in Colorado Springs last week, and our president of our space and intelligence systems, Bill Gattel, talked about space as being the dial tone of our generation. We all take it for granted that the dial tone is there, and these days we take it for granted that we drive somewhere, we've got GPS, we listen to, satellite radio. These are some of the things that are on the quote on the right there. And I think of geointelligence as being democratized in that same way, that, we just expect things to be there. And I think it's coming where our geointelligence is built into the applications that we use every day, whether it's in a business setting or in a personal setting. And the real reason for that is I think the producers and consumers are able to get together. So those that produce geointelligence are able to make sure they can learn from how people are consuming it. And really it's a developer-friendly world. So our platform and GSF's real focus was around this, making it available so that folks can really take it to the next level with geointelligence embedded in their applications. We also, the partners and platforms that are available today is unprecedented. The data that's available, the GIS applications that people take for granted, whole companies and whole industries are starting up around this, and I think that's another important part. Of course, what we want to talk about is some of the things that we bring to the table, which are our analytic engines. And for those of you that are familiar with these, you'll see that these are now capable of realizing the full scale of what they've been made for. And I think that's important too, because instead of just looking at a single image, or what if you could look at the entire globe and do something and find all the airports, find something at scale in that way. And I think that's a real important distinction here, that what geointelligence is going to be able to do at scale. Who knows? The sky's the limit. So one of the things that helps tell this story is examples. And I think, there's an importance of learning from how we're currently working with our clients. And I was able to pull out a few of our clients that I'm able to share. We have a number of clients that, of course, do things that we're not really able to share what they're doing. But these are the ones that we are able to share. And I want to really talk a little bit about them because I think they're very applicable. And these clients are running GSF in the background, but really you don't see that. That's something that's just behind the scenes. So Highland Hub is one of our strategic partners, Highland Precision Agriculture. And what they wanted to do is really take the multispectral data that they had, and they're looking at specific agriculture crops. And they wanted to offer that as part of a very large package service for farmers and for folks in agriculture. So they took the remotely sensed data. They also are on the ground. So they take a lot of their ground truth data and they bring that together. And what they're ultimately coming to, and you'll see on the right there, is they're getting down to a point where there's a possible infestation. And that's what that little alert is saying. And this is really a customized plan. Ultimately, the goal is to grow their yield. How do they produce more with the same resources? How do they be able to deliver more, and how do they maximize that? Well, behind the scenes, what's actually happening, and again, this is how they're getting started. They're working with a few farmers and a few acres or 100 acres. What if they wanted to do the entire country, or they wanted to do an entire continent? That platform that they've been building on, of course, is capable of doing that. So that's something that we feel very confident about, and we want to make sure that everybody on the phone, if you're interested in this, we're the ones that you can definitely come to understand how this might work, to get started and to scale. Another example is in the infrastructure or utility space. We've got a client called Edge Data, and they're looking at wind turbines and really looking at some of the generation, the assets that are generating from wind to power. And they really want to know some basic questions, and they're looking at, what are my assets? Where are they located? And what's happening to them over time? A lot of times people take for granted that these assets will be there, that they were built as they were designed to be built. Well, sometimes that's not necessarily the case. And then lastly, of course, is what happens if a storm comes through, a tornado or hail or lightning hits my windmill? What happens to that? And so these are some of the questions that we're answering using the Geospatial Services Framework, in addition to some of our analytical engines and our expertise. The last example, probably one of the most exciting, because it actually doesn't use as much of ENVI, but it uses IDL, which is our original language. And this is IntelliEarth, which is, full disclosure, this is part of Harris. It's a sister company of ours in the environmental area. But we put up a satellite payload called Himawari over the Eastern Hemisphere that looks at the environment, weather data basically coming in the Eastern Hemisphere. Recently, we launched one in the Western Hemisphere called GOES-16, which you may have heard of, and that was for NOAA. So these are 16 band or 16 channel sensors that, and again, this is definitely not my area of expertise, but they wanted to generate these products that have different environmental values and really do this at scale. So they did this, they wanted to use our processing framework, and you'll see here, this is sort of the way that they had architected, but the most exciting thing to me is actually showing what it looks like. And while I was thinking about doing a live demo, here's actually some screenshots of it, but this is taken, and you'll see the Eastern Hemisphere there. This is running through the GSF install that they have and running IDL algorithms to generate these various images that can then be viewed on a web application or a mobile application. So again, this is something that we feel we're very excited about, and we want to make sure that people understand the power of this. This can have millions of people looking at it, just like Netflix does in the video world. So again, very exciting stuff. And before I do that, I want one last question, and then Jamie's going to really talk a little bit more about the bigger ecosystem. So this question, Jody, next poll question.
All right. Do you currently use or plan to use one of the following? Amazon, Google, Microsoft, on-premise servers, or off-premise data center? Place your vote. All right, and here are the results.
All right. Thank you. Wow, that's interesting. You know, we hear a lot about Amazon being the leader and Microsoft really catching up fast, but it's a little bit of surprise that Google's catching on even faster. So, well, with that, I'm going to turn it over to Jamie to talk a little bit more about the entire ecosystem.
Thanks, Dan. Yeah, that's a great introduction into this overall geospatial ecosystem, and I just want to spend a little bit more time on this before going into some more detailed examples for everyone on customizing NV and GSF applications. So specifically, let's talk about the growing importance of scalability in geoanalytics. Dan has, really addressed a lot of these issues, but let's go back and what is this entire geospatial ecosystem? It's an integrated network of hardware systems, software developers, data providers, and business applications that are all working together to deliver information from geospatial data. So this is everything from sensors and data centers to satellites, drones, and IoT data, to data analytics and cloud services, to different revenue models, and obviously the market applications or your research applications. And of course, if you're at all familiar with what's been happening in this industry lately, you know that this is rapidly evolving. This is a real moving target. From just a decade ago, this network was dominated mostly by governments and large-scale commercial companies. Now, these same governments and large-scale commercial companies still play a significant role, but there's also a very diverse world of geospatial startups, from the small to the large. And so, with that in mind, consider the growth of small sat constellations, the ongoing improvements to medium and large-scale satellites, and of course the growth of the entire drone industry. Worldwide, these are all taking off. No pun intended. The entire market is growing at a remarkable pace, with new opportunities emerging on almost a daily basis. And so it's becoming really evident that scalability is going to play an incredibly important role for efficiently delivering information. This includes a few of the things Dan touched on, is that increasing spectral and spatial resolution of the sensors. There's an increasing temporal cadence. We're talking about being able to get daily imagery of the entire planet. It's pretty spectacular. But then there's also another issue of scalability, and that's where, again, where this, the advantage of cloud computing really starts coming in, is you've got increasing user demand and an increasing number of users. So you've got a number of different aspects of scalability that need to be considered. So we're no longer getting limited by sensor resolution or spatial extent or even your localized processing power. You're starting to be able to answer questions at a global scale in this new ecosystem. That's really exciting. To go along with that, where I want to kind of take this discussion now is, in order to get to this, this scalability, your workflows, your applications that answer your particular user needs or your client's user needs, these applications themselves need to be scalable, and that's what we've been doing. That's one of the things we've been doing. So next slide, please. Our first example, this is a customized geospatial application. It's called the HyCO Image Processing System, HyCO IPS for short. Tends to be a mouthful to keep saying the entire name. So this is a web application for on-demand processing of hyperspectral imagery from the HyCO sensor on the International Space Station. Interestingly, this was actually one of the first, if not the very first, application utilizing the ENVI engine as a backbone for on-demand, scalable, cloud-based geospatial computing platform. So we built this a few years ago when ENVI engine was really first being devised at Harris, and ENVI engine is just one of the engines, as Dan mentioned, that's enabled by GSF. And for those of you that aren't familiar, it seems like from our poll a lot of you are familiar with ENVI, but essentially this all comes together to put ENVI, which is a core image processing system, into the cloud and make it scalable. So HyCO IPS was a short-term demonstration project. Unfortunately, you can't find it online right now because we were only deploying it for a period from about 2015 to 2016. It was funded by the Center for the Advancement of Science and Space, which is a great group. If you're not familiar with them, they're responsible for a lot of the research and commercialization of the International Space Station. So the HyCO instrument was also a demonstration project that operated from 2009 to 2014 on the Japanese external module on the space station until a solar flare ended up taking out their onboard computer. I guess I should say, what is HyCO? HyCO is the hyperspectral imager for the coastal ocean. It was originally supported by the Office of Naval Research, and then in its last 2 years of life, it was funded by NASA. The data all lives on at NASA, so you can still access all of this data. And for those interested in those kind of details, HyCO, obviously hyperspectral, it's measuring in the spectral range from around 400 to 1,000 nanometers at approximately 6 nanometer spectral resolution and 90 meter spatial resolution. What was really unique about this, other than being on space station and one of the real earlier space-based hyperspectral imagers, was that this was the first one that was ever designed specifically to sample the coastal ocean. And therefore, we designed the HyCO IPS, of course, focused on the coastal ocean, so developing information on coastal water properties and benthic habitats and that sort of thing. What's really relevant to today's webinar is that not just this application itself, but what was built into the application were a number of custom workflows to derive our output products. So in these workflows, sequential processing steps are explicitly linked together all the way from the input to the output. So the user's selecting imagery and selecting what output they want, but then everything's strung together in the background. And what you see is then the live on demand, the output then comes back to you. So for example, as what we're showing here on this slide is output from deriving chlorophyll concentration in the Chesapeake Bay. So in this workflow, once the user would select the Chesapeake Bay scene, the workflow would create a landmask so that we're isolating just the water pixels for further analysis. Then we do a spectral resampling algorithm to transform the HyCO data into CWIFS bands. We then use a very common algorithm in the ocean sciences community called the OC4 algorithm for deriving chlorophyll from CWIFS data. We then ultimately take that output, apply a color scale to it, and through GeoServices, then display that back to the user interface. And then there's a small collection of other similar workflows in this application. So in the end, what we saw was not just the ability to develop a custom application, but the ability through ENVI and ultimately the ENVI engine and GSF to deliver this application and these workflows in an on-demand, scalable processing platform. So let's look at another kind of related example. Next slide, please. So this continues with the water theme, and in all fairness, we're not all about water, but that's just kind of the theme we chose here. These are two custom examples of two custom standalone geospatial applications, WaterMask and NDWI. Don't let the NDWI fool you as it's just a standard index. There's a lot more going on behind the hood of this. WaterMask is on the Cloud.io Geo Marketplace. This is a European-based company with a presence here in the US as well. They provide like an online infrastructure for integrating everything from data providers and software developers to scalable processing. So it's kind of an app market, the idea of an app marketplace within the geospatial industry. Similarly, the NDWI application is on the Precision Hawk algorithm marketplace, and if you're not familiar with Precision Hawk, they work specifically with drone imagery, and they're also building a kind of an integrative platform for pulling together lots of different geospatial applications, but again, all related to drones. Both of these applications use the ENVI engine, GSF, and as you can see, they have the same purpose ultimately, and that's as simple as delineating the presence and extent of surface water. But under the hood, they're quite different. Despite the same focus, there's a lot of different algorithms and stuff going on underneath. So, as an example, WaterMask is focused on utilizing well-calibrated government satellite sensors. So this is Landsat 8 and Sentinel-2 currently. And so we can rely here on stringing together some well-established algorithms with empirical relationships and fixed thresholds for delineating water. However, with NDWI, even though you could do something similar with that, if your system was well calibrated, it's sort of the Wild West to some degree within the drone market in terms of sensors. And so we needed to be able to work with both calibrated and uncalibrated sensor systems. And of course, there's a wide variety of them. So we used a different set of algorithms here with a dynamically generated threshold to differentiate the water features. So it uses the scene characteristics to then separate out water from land. So in both cases, these are applications of discrete, automated, on-demand applications that are designed to meet a specific need. So it provides what's a relatively simple piece of information, where is water, but this is incredibly valuable for a number of different areas such as water supply management, flood assessment, water quality, coastal and inland aquatic analyses, etc. Importantly, to use either app, there's no need for any remote sensing expertise. So this is getting into what Dan was talking about, linking your producers and your consumers, is you don't need to be a geospatial expert to use these. All you do is select your study area or you upload your own imagery, and the output products are generated automatically. Furthermore, the outputs in ready-to-use file formats, such as GeoTIFFs and shapefiles. So even if you're not on the shapefile side using GIS, and you literally just need something for immediate visual interpretation and directly putting into your reports and presentations, you can take those GeoTIFFs and do that. So it's robust both for the experts and the non-specialists alike. As I mentioned, we're not all about water. These are just two examples. We're going to be releasing many more applications in the near future in areas such as vegetation, urban development, minerals, etc. But what we're really doing is, in reference to this webinar, what's important here is that the applications themselves can be readily scaled to accommodate large volumes of imagery and large volumes of users. So they're building on this system of ENVI, the ENVI engine, and GSF. We can inherently handle scalability. Additionally, the algorithms or the applications themselves are, it's software. It's readily portable. So that means rather than kind of the much older paradigm of bringing our data down to the applications, this allows us to much more easily move the applications to the data. And this is obviously a key benefit of cloud and server-based geospatial processing. So ultimately, it's not just data on demand, not just software on demand, it's information on demand. And now let me turn it back over to Dan for some concluding remarks. Thank you.
Great, Jamie. Thank you so much. And for those of you that joined a little late, high-speed computing is one of our key partners in really developing and producing the algorithms and the information, and being able to democratize that across various providers such as Precision Hawk, Cloud.io, it could be Esri, it could be DG or Airbus, the folks that we work with. This is just a wonderful example of bringing your analytics to the data. In summary, I'm going to talk a little bit about the final benefits and really wrap up why GSF was created and around the three different points: cloud native, data agnostic, and the ability to really get GeoINT out with producers, consumers in a developer-friendly way. We think that that's very important for every organization, to think of it in those terms and really to understand how GSF can be a core component of your infrastructure and your ability to deliver on-demand and batch geoanalytics at scale. So with that, I think we're going to say thank you and open it up to some questions. Jody, do we do that on the phone as well, or do we just take some of the questions that we've been getting over the chat channel?
Yeah, we just take them over the chat. Okay. So at this point, Dan and Jamie will address some of the questions that have come in. As a reminder, you can type in the question into the questions chat area on your GoToWebinar dashboard. So with that, one of the questions, the very first one was from Marie. She said she didn't see the NOAA satellite data on your slide number 22. Are we working with them? NOAA's big data initiatives is putting the data on Google or Amazon Cloud. So I guess the question is, are we working with them?
Yes, I can talk a little bit about that. We were the software provider that our environmental group came to us and asked us about that. We do work with NOAA as well, and they're working with NOAA as well as, I believe it was the Japanese Meteorological Society or something that on the Himawari one. But they are putting their data both on Google and Amazon regarding that, and then they're building applications off of that for various consumptions. And we're also looking at offering some of that information to be available for purchase in the commercial market through our Harris Geospatial Marketplace, which you can find at harrisgeospatial.com. In addition to GSF, we also have a marketplace where that information will be coming soon. So hopefully that answers your question, Marie. And then I see you want me to answer that next one from Joe. Just
sure.
Talking, we have one, question regarding relationships. One of the things that we use in this industry is we're all cooperating to really push geointelligence and that democratization part, really push it along and make it more mainstream, make it more ubiquitous in today's world. It's no longer about like business intelligence and big data and all. They're not all separate. All of these are converging, and we believe that they're converging in a geointelligence way. We work with many partners, and HySpeed's computing, they came to us, Jamie came to us early on with a problem, how do I get this data out on a way that is web enabled? And that's something that we valued in learning from them. We work with Cloud.io, as you mentioned, and Precision Hawk, and they're running Envy and IDL. We also work with Esri, of course, and Digital Globe, Airbus, Planet coming along. We welcome all of it. So we really do have this cooperative ecosystem that we're all trying to push forward to make more geointelligence capabilities available to more and more folks, and making that simpler and simpler. So that's their role working with us. So hopefully that answers that question.
Yeah. So you mentioned GOES 16 having multiple consumers hitting the web page in the cloud, I assume. Do you have a number of concurrent users to understand how many users you can handle at once?
Well, that's an excellent question, and we do not have that under what I would consider, current operations. We're not actually doing that, but the technology that we're based on, I gave a early slide about at scale. They're handling with the same core foundational platform called Node.js. They're handling Netflix. So if you're familiar with the consumer brand Netflix, where they're distributing video files, I believe they have 99 million members right now, or as of yesterday, that watch 125 million hours of video every single day in that way. So the scalability is more around the function of money and how much do you want to pay. And I think that the platform we've based GSF on is really capable of those same numbers.
Great. The next question, what parts are open okay, wait, hold on.
I can address that. So there's a question regarding open source versus our proprietary. So, open source software is readily available these days. And, there's a number of them out there. If you go to GitHub, any of the open source communities, those are available for you to use. What we tried to do is take that open source software and really focus it on our particular GeoINT issues. So what we did with Node.js is we took that and we used about 80% of Node.js in that way, and then we put about 20% of our secret sauce in that, and we've made it a proprietary that you need a license for, or excuse me, you need to pay for, and that's because we want to support it. We want to support it both today and in the long run. So we continue to add to it. So we do charge an annual fee and a maintenance, a software maintenance for this if you're going to run it on your server. And you're basically enabling that for your site. So GSF does have a price. It's what we consider to be somewhat small price relative to the benefit it's providing, but we want to continue to really move that forward with hooking it up with all the latest and greatest providers. So Amazon S3 buckets, Microsoft Azure. We want to make sure it works with Google Cloud's big query engine. We want to make sure all those things can be at your disposal when you're using GSF. So therefore, we have a team that, which is why we need to charge for it. So that's the business we're in.
Great. To lead into that, how can scientists and academics get benefits of this network?
Jamie, do you want to?
Yeah, I can handle that. So I came out of my background as in the science research world, academic research world, and some of the early applications, for instance, on the HyCO IPS were derived from my own academic research. And so what I see is getting involved is it's becoming increasingly easier to take your research code, your research algorithms, and transform them into operable applications. And it continues to grow easier. And because of the portability and the scalability aspect, once you develop, so for instance, our code, our applications run both like desktop NV and as well as on the GSF level. So once you get it developed at one level, you can apply it across a wide range of possible clients, customers. I mean, it doesn't have to be customers. It can just be other scientists. It becomes much easier to share and distribute applications as well.
Great. Any plans to work on an object-based classification engine such as Trimble eCognition?
We would welcome that, to work with Trimble. We don't currently have that in our backlog, but it's something that we're always looking for business partners. So it's one of the things you can contact me. I may not be the right person to work on that, but we're always interested in bringing more customer value into our platform. So.
Great. Is GSF useful to deliver raw or classified LiDAR data or LAS files from other software, such as the PIX 4D?
I can take that. Yeah, the part of the tenets of us being data agnostic is that we want to be able to handle that. And so yes, we do work with that. That's something that it's continuing to evolve in how we deliver it. One of the big areas in the delivery and the visualization is moving from what Jamie mentioned about downloading the output, downloading the visualization, to more streaming. And I think you're all familiar with that in the video example. Your hard drives would be full if you downloaded all the videos you watched on Netflix, but you stream it, so it's not actually there. And we're looking at various ways to stream this large, heavy, huge data, whatever word you want to use, such as the LiDAR, and we are definitely, one of the creators of that with Geiger mode LiDAR. So we continue to evolve in those areas, but yes, we do work with that.
Great.
One more? You got one more in there?
Yeah. Let's see. I'm not really sure if this is, okay. So recent platforms such as Synagrius.
Yep,
I don't know how to say that.
I found that question, yes. So I'm going to summarize this. That's an excellent question. There's recent platforms, and there's a few of them that are listed here. So they already sort of permit you to do this, and you can upload and download results for free. And the question is really around how do we differ from that? Those platforms exist today, and those are wonderful platforms. We use them. And I think every data provider is now providing a platform, and some of the European space agencies also, the various countries are providing platforms. We love those. GSF is different in the sense that if you wanted to create your own platform, you really wanted to run this for your company, your organization, your school, your enterprise, you would purchase GSF from us, and then you would be able to build that exact same platform and monetize it in the way that you monetize it. It might be for academia. It might be just for the sake of science or solving real world problems with populations in the world, where they're moving, what they're doing. We allow stuff to be taken, and you can purchase that from us and then run your own analytics and provide it to your user base. So that's the difference between what those folks are doing with their platforms and what we're doing by selling server software. So hopefully that answers your question.
Great. With that, we're going to wrap things up. If we didn't get to your question, then someone will follow up with you. And just a reminder that we're going to have a recording of this webinar on our website at www.harrisgeospatial.com in the next 24 hours. An email will get sent to you in the next hour or so with the link to the webinar so you can rewatch it. We appreciate everyone's attention on the line, and thank you again, Dan and Jamie, for the informative presentation. Have a great rest of the day.
My pleasure, and contact us at any time.
Yeah, thank you, everyone.